Hey, hello guys. So in this video, we are going to discuss about this problem named ThreadSafe Two Sum Checker. This is like a lead code problem which we have seen. So if you have seen the two sum problem array and you have been asked to find all the pairs which are equivalent to the target. So this is like the same way, but we have more concurrent situation. So what is going to happen here is we to design a shared data structure where multiple threads are able to insert the numbers and check for the two sum pairs also without any race condition. So in that lead code problem which is of two sum, there you were getting the array with a specific size. Here it's more like a streaming that hey, multiple threads can keep adding the numbers to the array, and on the other end you have to keep calculating the two pairs which are for a particular sum basically. The requirements are you need to create a single shared data store where you are storing all the numbers which have been added, and you need to design the operation two operations. One is the one is add, and other one is the check pair. Add is just where the thread will call for the number. The check pair will return whether the number exists or not. We need to make sure all our operations are thread safe. Now, one of the easiest solution here could be that hey, we can the hash map. We can use a concurrent hash map, and because the concurrent hash map automatically have a inbuilt log, so they when you are adding any number there, if you are reading or writing, irrespective of the type of the operations, range of the keys will be logged, and that way you will be able to handle the race condition. But let's see here. So here you will be able to add the number. Check pair you will be able to find the pair. Okay, this is one of the way to. But in this question, there's a problem. If you use the concurrent hash map, you are doing the locking for everything, for writing also, for reading also. So I mean that is not required basically. What if we can have more granular lock base? What we if we can have more control over the locking. Right now there's an inbuilt lock with the current hash map. They kind of log the range of the keys there. What if we can have have a more specific locking, the granular locking? So for that we can use this read write lock, where you can differentiate between whether do you want to add the lock for the read or write, and if you see you have created a set of numbers. Here we are not using the concurrent hash map because that is not required now, since we are going to have the control over the locking by ourselves. That's why we are that is here. If we see read write lock, which whenever you are going add a number, you are locking the write only. Basically no one will be able to run write operation, but if anyone want to read it, that will be still possible. This way we are having more control over the lock. Similarly, when you are checking the pairs, here you are only locking the read. You are not saying hey do not you are not saying hey don't allow anyone to add the number, because it doesn't matter. Then you are basically checking with the number. Once you are done, then only you are kind of releasing the lock. Here we are able to have more granular kind of locking. In the previous solution, which was concurrent hash map, it was more of an inbuilt lock which was locking either you do the read operation or write whatever. But here we are having the control for the lock. Okay. Now if we talk about, so in the concurrent hash map, it allows you the concurrent read and limited concurrent writes. Yes, it allows you the concurrent, but not for the same keys, not for the. I'll discuss this more separately. Now, what are the other problems which we have in this? If you have seen the way we are calculating the complement or the way we are finding out the two sum, the chances are high that you will duplicate it. That hey, you may find out the duplicate pairs. What if the number of the producer is overwhelming? What do we mean by that? Is what is the number of the threads who are pushing to the store become significantly high versus the one who are trying to calculate the two sum? What will happen so that we are going to we will discuss about the current hash map little bit more detail. Yeah, so in concurrent hash map we do the segment based lock. So what happens is if you just use a simple, if we just use the simple hash map, that case it kind of do the entire locking the entire hash. In case if you are using the synchronized hash map, but if when you are using the concurrent hash map, it divides that internally divides the hash map into the multiple segments, and locks happen on the segments. If a write is happening on a particular segment, then not the entire hash map, only a segment which may contain multiple keys will be locked, not the entire. Now for the reading purpose, in most of the cases it does not require the locking, but in few or maybe edge cases it may be that we can look at. But for most of the cases it does not require any locking there for the concurrent hash map. Now here we are storing the set of the numbers in this and right. But what if we want to find out the count of the pairs which we have for the given sum? Right now we can find it out. Hey, that hey, this is the that hey, the sum is available for this range, but we cannot find out the number of the pairs which we have for this one. So that is the only this that is the only sorry, that is the also an issue with this solution. There are other issues with both of these solutions. As we keep adding the numbers, the chances are that we are kind of log the entire memory. If let's say if you have got the 1 million numbers onto the same hash map or the map whatever we are using, it will take the entire memory of your server. So that it can be also optimized with a more better solution. So all those things we are going to cover in our course, including about duplicates and how what if the producer over and all those.